Alrighty, hello everyone. We're going to be taking some quick notes on limits. So starting with a formal definition of limits here, it says let f be a function defined on an open interval containing a, except possibly at a itself. The limit of f of x as x approaches a is equal to L. If for any epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of the difference between f of x and that limit is less than epsilon, where the absolute value of x minus a is also less than delta. Now that sounds like a very formal definition for limits, and for the sake of simplicity for this class, what I really want you all to define a limit as, or be able to do, is to interpret a limit and be able to translate it from mathematical notation to English. So I can see here that if I have a limit, and this is its formal notation, you can read this as the limit of f of x as x approaches a is c. Okay, so for our first two exercises, we're going to keep it real simple. I want you guys to be able to translate this limit into English. So, starting with the very first example, I can rewrite number 1 as the limit of f of x as x approaches 2 is 5. Okay, and similarly for number 2, I can rewrite this limit as the limit of g of x as x approaches pi, and we know that pi is a number, is -1. Okay, moving on to our second set of notation, you might notice that this notation looks extremely similar to the last one we just observed, the only difference being that now I have a positive sign next to a and a negative or a minus sign next to a as well. And these signs are going to be indicating which direction we will be observing each limit. So we can read a limit that has a positive sign as the limit of f of x as x approaches a from the right. Meaning that if I have a negative sign, instead of observing it from the right, we're actually going to be observing it from the left. So I'm going to go ahead and write that in as my interpretation for my second limit. I would say that the limit of f of x as x approaches a, I'm going to erase this real quick. There we go. As x approaches a, but this time we're going to be saying from the left is c. Okay, so anytime that I am observing a limit and I have a positive sign next to my x value here, this number, I'm going to be observing it from the right, and when I have a negative sign, I'm going to be observing it from the left. Okay, and in order for a limit to exist, there needs to be an agreement from both the right and the left side. And you might recall from Mean Girls, LOL. Now, in order for a limit to exist, there needs to be an agreement from both the right and the left. And this tells me that there's also a possibility for limits not to exist. And I don't know if you guys have ever seen Mean Girls. There's like a certain part where she's like doing a math problem for calculus, and she's like, the limit does not exist. Well, yeah, that's because limits can not exist and they can exist. And in order for a limit to exist, it says here that there needs to be an agreement from both the right and the left side. So mathematically speaking, the limit of f of x as x approaches a exists if and only if the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left. Okay? So we're going to go ahead and jump into some actual problems here so you all can see a little bit more about what I'm talking about. Now, when you read a graph, you always read it from left to right. when you evaluate limits, imagine a little man walking along the path of the curve and always analyze his path from both the right and from the left. Okay, so we're going to start off here with A, and we're going to be observing what is the limit of f of x as x approaches 0. As you can see from all of these problems, I'm going to be observing 0 from different directions. So I'm going to go ahead and just highlight x is equal to 0, because that is the point or the x value in which I'm going to be observing this limit. So now the first thing I'm going to do is I'm going to observe the limit of f of x as x approaches 0 from the left, because I have this negative sign. So I'm going to start on the left side of my function, and I'm going to get really close to 0, as close as possible. I'm almost getting to that yellow 0 value. And as I get closer and closer and closer and closer, I can see that I'm approaching the y value of -1. So I'm going to say that when I am looking at the limit from the left, I'm approaching -1. Okay. Now let's go ahead and observe the limit from the right side. So I'm going to start on the right, and I'm going to get closer and closer to that yellow value, tracing my graph. And when I finally get to that yellow 0 value, I am touching 3. Now, in order for this limit to exist, the left and the right side have to match. In this case, the left and the right side do not match, because the left side is at -1, the right side is at 3. So in this case, the limit does not exist. And I use DNE as a acronym, does not exist. All right, let's go ahead and observe the limit. And this time, x will be approaching 1. So I'm going to use my highlighter, and I'm going to say, I'm going to be observing what is happening at the function when x is approaching 1. So this time I'm highlighting 1, right? Because all of these are approaching 1. Okay, so now I'm going to go ahead and observe the function from the left. And so I'm going to trace the function from the left. I'm tracing. Here, there's a jump. It's going to jump up here. And as I get to my yellow, I'm approaching the y value. This is the y value of 1. So I'm going to say the limit from the left is 1. Now let's go ahead and observe the limit from the right side. And as I trace my function from the right side and get closer and closer to 1, I am also meeting it at the exact same y value of 1. So for this example, you can see that the left and the right side of the function match up, and the limit from the left and the limit from the right is equal to 1. So because both sides are matching, I'm going to say the limit of f of x as x approaches 1 is 1. And in calculus, it's always good practice to justify our answer, and I'm going to say that my justification here is that the limit of f of x as x approaches 1 from the left is equal to the limit of f of x as x approaches 1 from the right. So that's my justification, and here's my final answer. Alrighty. Moving on to my next example. This time I'm going to be observing the function as x approaches -2, -2, -2, -2. So I'm going to highlight my function at the x value of -2. Okay? And so let's begin by observing the function from the left side. So as I approach -2 from the left, my final y value is at 2. Okay. Now let's observe the function from the right. I'm tracing. There's a jump discontinuity. And I end up at the same y value of 2. So because the left side and the right side match for this limit, we're going to be saying the limit of f of x as x approaches -2 is +2. And I'm also going to be writing my justification for good practice. And we would say here that the limit of f of x as or I don't have to write as because I'm going to use my notation here. X approaches negative 2 from the left is equal to the limit of f of x as x approaches negative 2 from the right. Great. Next example. Okay. So as some algebra review, I just kind of threw these in here so that you all can see the difference between limits, which are an approximation as we get closer and closer to a particular x value, and actually evaluating a function at these x values that are in my parentheses. So just for good practice, I threw these in here. And so we're going to be evaluating the function graphically at these specific x values. So looking at my first function, or my first example here, it says, what is f at negative 2? So this is my x value, right? And I'm looking for the associated y value. So at negative 2, here's my x, I have a y value at 2. Okay? Now, next one. Here it's telling me when f of x, when you observe it at 0, right, here's 0. What is the y value at 0? Now, I have 2 points, or it looks like 2 points at the value of 0, but one is a hole and one is a actual point. We know this is a hole because it's an open circle, and this is the actual point because it's a closed circle. So the value at 0 is going to be 3 because this one is a hole. So I'm not going to be evaluating the function at a hole, right? And last example here, if I'm observing the function at 1, here's 1, another example where there's 2, what seemingly looks like 2 points at 1. This is a hole, this is a closed circle, so I'm going to say the actual value of the function at 1 is negative 1. That's the y value of this point down here, okay? So just some extra practice of evaluating points on a piecewise function. Okay, now we're going to get into looking at some new examples and evaluating some of these limits. So I encourage you for the next following examples to pause and try some of these on your own and then continue the video to see if you get it right. So here I'm going to be observing the function as x approaches 4. So I'm going to go ahead and highlight my x value of 4. Okay. And now we're going to be observing what is the limit as I approach 4 from the left side. Oh, no, sorry, it's starting with the right side. So I'm going to go ahead and trace from the right side. And I'm approaching 4. And I get to the y value of negative 3. Okay. Now, let's go ahead and trace this function. We're going to be observing it from the left now. And as I trace from the left, I also end up at the same y value of negative 3. So because the left and the right side match, I know that my function, the limit of f of x as x approaches 4 is negative 3. And do not forget your justification. So here I would say the limit of f of x as x approaches 4 from the left is equal to the limit of f of x as x approaches 4 from the right. There's my justification. Moving on to my next example. And now we're going to be observing this same function as x approaches 7. So I'm going to go ahead and draw my line here. Great. And we're going to be starting observing this function from the right side. So as I trace the right side, as I trace from the right side, I stop at the y value of 6. And as I trace from the left, tracing from the left, I approach the y value of 6 as well. And the left side and the right side match, so I know the limit of f of x as x approaches 7 equals 6. And of course, I'm going to write my justification all the time for good practice. And I want to see the justification on your papers also. All right. Okay. Here, I'm going to be observing my limit of h of x as x approaches 1. So I'm going to go ahead and highlight 1. And we're going to start by observing this limit from the right side. So from the right, I jump down and I reach -3 as my final y value. And I'm going to go ahead and trace from the left now. And I meet at the exact same y value of -3. Both sides match, so I know my limit of h of x as x approaches 1 is -3. And you already know I'm going to write this justification. Oops, this is in h of x. Make sure your notation is always correct. Beautiful. All right. So same graph here. I'm still observing h of x, but now we're going to be looking at the x value of 3. Okay. So when I observe this limit from the right side, I'm approaching the y value of 4. When I look at the left side, I'm approaching the y value of 1. And the left and the right side do not match. So I'm going to say that the limit does not exist. And for my justification, it's extremely similar here. Except I say that these two do not match. The limit of h of x as x approaches 3 from the left and from the right are not equal. So I'm using a not equal to sign right in the middle for my justification. I encourage you all again to pause the video and try these out on your own before I do them. And hopefully you've had a chance to go ahead and try them out on your own. So I'm going to begin by observing the limit of g of x as x approaches -4. So I'm going to be getting really close to -4. And I'm going to observe each side individually. So first I'm going to say, what is the limit as x approaches -4 from the left? And what is the limit as x approaches -4 from the right? Okay. So as I look at this from the left side, I'm getting really close to my y value of -4. And from the right side, I would trace all of this and get to the same y value of -4. So because the left side and the right side match for this particular function, I would say that the limit of g of x as x approaches -4 is -4. And always I write my justification. And I know that the left side does match the right side. So there is my justification at the top. Okay. Now let's go ahead and move on to our next example. Now I'm going to be observing the limit of g of x as x approaches 2. Okay, so let's go ahead and observe what is going to be the limit as I approach 2 from the left and as I approach 2 from the right. So if I approach 2 from the left, I'm tracing from the left, I'm tracing, and this function is actually going to keep going up. We know that when a function looks like this, there really should be an upward facing arrow, and we know that this is going to continue up to infinity, right? So from the left, I'm going up to infinity. And from the right side, I'm actually stopping at the y value of -3. So because infinity and 3 do not match up, I would say the limit does not exist. And my justification here is that the left side and the right side are not equal. All right, last one for this particular function. And I'm going to be observing this limit as x approaches 0. So looking at 0, I'm going to be looking at what is my limit as I approach this 0 from the left and as I approach 0 from the right side. So when I'm approaching 0 from the left, I'm getting really close to the y value of 0. And as I observe the limit from the right side, I'm also approaching 0. And because both sides match, I know that the limit is going to be 0. And one final justification for this function of g of x there it is. Alrighty. So I highly encourage you to try this one out on your own. I know that if I observe the limit of j of x, as x approaches -6, from the left side and the right side, they both match up at 0. The y value is 0. So I would say 0, and then you write your justification. I'm just going to breeze through these because I'm trusting y'all to do these on your own. And I know that the limit as x approaches 0 from the left gets close to 0, and from the right also gets close to 0. So this one's also 0. And again, I want to see your justifications, right? And then as x approaches 2, let's see here. As x approaches 2, from the left, I'm getting really close to the y value of 1. And from the right, I also get close to that y value of 1. So all three of these have a limit that exists. Make sure to write your your justifications. Alrighty, I'll see y'all in the next video. Thank you.